Hi, everybody, and welcome back. So the last couple of videos that you've looked through have been all about control flow. So we learned about if and else, we learned about while and break, and we learned about for loops. And notice, though, that inside of those curly braces, all of these functions, they had curly braces, and inside of those curly braces, you would write some computer code, some R code specifically, that would do something. And we said that this was an expression, okay? Now, one of the downsides to while loops and for loops and if-else statements is that the objects that you create inside these expressions end up in the global environment, which means that they are not self-contained. And not only that, but it can interfere with code that you write later on, okay? So you probably noticed that when you wrote a for loop that used I or J, then in your global environment, you ended up with an I or J in your global environment. If you created, so if I go back to control flow and I look at this X rand is in your global environment. If I look here, the J is going to be in your global environment when you run this code. Right here, I've got the Fibonacci results. Yes, this is in my global environment, but if I had created something else inside of here that would also be my global environment, these like intermediary steps. So right here, has date and attempts are also going to be in my global environment. And if I create anything else in these inside of these curly braces that are all part of this computing, it'll end up in the global environment. And this is kind of like this is basically the computer science version of littering. Okay, so think about littering like you're driving down the street and you've got a wrapper for your taco or your hamburger or whatever it is that you've got, and you finish eating, you roll down your window and you toss the trash out onto the street. Okay, that's a horrible thing to do. Okay. You're making a mess in the world that you live in for no reason. Okay. Realistically, you should be keeping that trash in your car. And then when you get out of your car, you walk into the building, you put it into the rubbish bin or put recycling into the recycling bin, whatever. You don't just throw it out on the street. All right. Now, so the for loops and the while loops, a lot of times the stuff that happens intermediary, like the food wrappers, if you will, they just get tossed out into your global environment to junk up your global environment. And then you have to go through and actually remove that stuff with either an RM command or you have to clean up your global environment. And it's just a pain. Like, why? Why wouldn't you just write your code so that your code is clean so that when you start your computation and when you end your computation, you have what you started with and you have what you ended with. You don't need all of the stuff in the middle junking up your memory, junking up your global environment. That's where functions step in. So there is another reserved word. So we talked about here that if, else, for, while, in, break, all of that stuff. These are reserved words. Another one is function. Okay, so you can't mess with this. You cannot overwrite the word function, and you shouldn't try to. But we can use functions to get around this or to prevent the intermediary computations from clogging up our global environment. And it's actually really cool the way that this happens. Um, and it helps a lot, especially if you have really large data sets, because you don't want intermediary large data sets also being stored in your global environment because that's taking up memory on your computer for no reason and you don't need it at all. So that's where functions come in. So the way that we write a function, we're going to have the word function. We have the arguments. So this is what's going to go into the function. And we have the expression right here. So we see that inside of the curly braces, there is an expression. This expression is print hello to me. Hello, Dr. Gabriel. Okay. And then if you want to call this function, if you want this function to execute, then you type the function with open close parentheses. Okay. So this is pretty simple here, but we're going to talk about this. We're going to wrap our heads around it because if you can wrap your heads around functions, this is some of you before you started the class, I promised you superpowers. This is where you get your superpowers. Okay. It's complicated. It can be very challenging to learn, but my goodness, once you wrap your head around functions, you will never go back. You will be able to do literally anything. It's amazing. It really is. You've already learned a lot of really, really powerful things that you can do between reproducible reports in Quarto, these amazing, beautiful graphs in ggplot, cleaning and wrangling data with mutate and stringer, and just how kind of how R works with the vectors lessons. But this stuff right here, and I mentioned a couple videos ago at the top of this lesson, this is high risk, high reward. If you can get this stuff, my goodness, your data science and your research skills will just go through the roof. Okay. All right, so let's talk about what's going on here. I'm creating an object called geometric mean. So functions also are objects. And this function will take in two arguments, a and b, and it will perform a calculation. So this is the expression. The expression is take the square root of a times b. So we get from like a math textbook that this is the definition. This is how the geometric mean is defined. Also, if you've never seen this before, if you see a colon in front of an equal sign, or if you see an equal sign with 3 bars, it means is defined equal to. So this function of x1 and x2 is defined to be the square root of x1 times x2. So that's the geometric mean. All right. And whenever we write this function, the arguments are going to be what is available to the inside of the function. Okay. So if I want to take the square root of a times b, then the function is going to need to have arguments for a and b. Okay. That's just how it works. And anytime we create a function, we have to test it. So we know that, let's see, if I do 5 squared is, or 5 times 20 is 100, squared of 100 is 10. So this geometric mean of 5 and 20 should be 10, and it is. So anytime you write a function, you immediately have to test the function. We actually did that right up above here. So when we wrote the greet me function, we immediately tested it, and we got the results that we were looking for, okay? So you write a function, you test a function. Later on, whenever we're talking about function best practices, which is the kind of the next section, it will be write a function, document a function, test a function. So the documentation for the function, super, super important, but we'll talk about that a little bit later. So function syntax, okay? So we have a function name, we have the word function. This is the reserved word in R, and this is what we use to create functions, just like you use the lowercase c to create atomic vectors, or you used the command list to create non-atomic vectors. This, you create functions with the word function. And then inside of the parentheses are the arguments of the function. Inside of the curly braces is an expression. So this is a set of contained R code that uses the arguments. Technically speaking, you can write functions that don't have arguments and don't use arguments. And we saw an example of this right up here, that every single time it literally just says, hi, Dr. Gabriel. Those functions, sometimes they can be useful, but a lot of times they're kind of boring. Most functions that we were going to work with are going to have arguments. And so this expression is going to be a lot of code in R over multiple lines, and R functions are designed. Anytime that you write a function with the command function, it's kind of the only way to do it. It's going to let you do whatever computation you want to do on in between these curly braces, but whatever happens on the last line is going to be the output of the function. So you can do a whole bunch of computation, like 50 different lines of computation. That stuff is not going to be sent back out to the global environment. Whatever you put on the very last line of the function, that is what's going to be returned to the global environment, okay? Now, if for some reason we need to return something earlier, like if we have an if statement that says, okay, well, do this computation, but if you see that all of the values are equal to 0, then there's no reason to do the rest of the computation down here. So just return some intermediary results. So right here, I told you above to use an if-else statement to write the absolute value function. So that was one of the exercises that we had in a previous video. We can write the absolute value function as a function now. We don't need to use an if-else ladder. We're just going to be using the if part. So we say, okay, we're going to initialize the out value. And if we say if the numeric value is greater than 0, then do nothing, just return whatever that numeric value is. However, if it is not greater than 0, then multiply it by 1 and then return it. So this is the last line of code if you don't return early. Okay, so we're going to test this function. We're going to give it a +5. So num comes inside here. out gets saved to be the word num, and then we compare, is num greater than 0? 5 is greater than 0, so I immediately just return 5, okay? But if I tested it with -5, I'm going to save -5 into out, and I'm going to check, is num greater than 0? No, that's not true. So this will not happen. This return will not happen. It's just going to get skipped, okay? And the next computing, and technically the last computing, computation will be to multiply -1 times -5 and return +5, okay? So here's an exercise. I want you to, we're going to stop here and we're going to pick up with function best practices next. But do these exercises and go back and read the section on programming in this book called Hands-on Programming with R. So this book, they include the material on functions like in very first lesson, like lesson 1. And I personally think that because functions are so powerful and flexible, they need to be introduced later in the semester. So that's why I'm holding off, even though the chapter is literally titled The Very Basics. I'm holding this off until sort of the end of the semester because I do think that you need to get through a lot more things before we introduce functions to you. Maybe this is right, maybe this is wrong, I'm not sure. Give me some feedback, tell me what you think. But do these exercises and well, they'll take you a little while to read this chapter, so see you in an hour or two. All right.